Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video is the beginning of a bunch of videos on non-right triangle trigonometry for a trig course. This really opens the gate for us to deal with really good applied problems that do not involve right triangles. And it's really based around just two theorems, one being the law of sines and the other one being the law of cosines, very aptly named theorems. This video is just dedicated to the theorem and proof of the law of sines. So let's go ahead and start with the law of sines here. In a triangle, and by the way, it doesn't need to be a right triangle, it's just any triangle ABC, we have the following. The sine of the angle A is to the side of A, as the sine of angle B is to side B, as the sine of angle C is to side C. Let me give you a visual of this. We have a triangle, and it's not a right triangle, with angles capital A, capital B, and capital C. That's what that little, these little things here denote to me, means a capital. And then the sides opposite each of those angles will be the lowercase letter. That is, the side opposite angle capital A will be side little a. The side opposite capital B, angle capital B that is, will be side little b, and side little c will be opposite angle capital C. And what the theorem, the law of sines, is telling us is that the ratio of the sine of that angle A to side A is the same thing as the ratio of the sine of angle C is to side C, or sine of angle B is to side B. It's a pretty amazing statement and actually creates several equations that we can relate to one another. Also, you may see this in a textbook written slightly differently. They might write it the other way. So if two numbers are equal, their reciprocals are equal. So side A over sine of angle A is the same as side B over the sine of angle B, which is the same as side C over sine of angle C. So these are all the same statements. And it really does create a very, very nice relationship between all of these sides and angles. Now, the proof of this theorem is actually not too terrible. We just have to draw in one more thing, which is the altitude of this triangle, which I have drawn there in red, and that altitude makes a right angle within this triangle, which basically breaks that triangle into two right triangles. And so what we're going to do is just talk about the sines, since it's the law of sines. We're going to talk about the sine of the angle A and the angle C, since those are the ones that are opposite that vertical red altitude. And by the way, that red altitude, I'll just call H. It's the height H. Well, if we recall from our right triangle trigonometry, the sine of angle A should equal opposite over hypotenuse. So H over C. That is, H is equal to side C times the sine of angle A. But at the same time, we could have created a relationship for angle C, side H, and side little a. And that would have been this. The sine of angle C is, again, opposite over hypotenuse in its own right triangle. So opposite being H, hypotenuse being A. And that would imply that H could also be written as A sine of angle C. Since these h's are the same in both cases, that's just the same h for both of those right triangles, This means that these two values of h have to equal one another. That is, I'll write thus, c times the sine of angle A must equal a times the sine of angle C. Well, now all I need to do is divide both sides by AC. If I divide both sides by A and C, I will get sine of angle capital A divided by A is equal to the sine of angle capital C divided by side C. Now, I arbitrarily labeled these sides A, or these angles A and C. I could have labeled, for example, that angle right there as angle B if I wanted to. And so therefore sine A over A is the same thing as sine of B over B. In other words, it doesn't really matter what the lettering was. It's sine of an angle is to its opposite side as sine of another angle within that triangle is to its opposite side. And therefore we have proven the law of sines. Not so bad, right? And in use, like when we go to use the law of sines, it's actually pretty straightforward with the exception of an ambiguous case. So before we head into examples, I want to get a conceptual visualization of the ambiguous case, because that's going to play a key role in your success for the law of sines. So despite having just learned a theorem, we're not going to use it immediately. Instead, we're going to visualize an ambiguous case with this and then go into examples.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way, cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close, don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.